Hey guys, welcome to Ann's Maths Club. My name is Nyakinyo Gadura, or you can call me Mwalimu Ann. I'll be your teacher for today, and I'll be taking you through the topic Surds. We are going to do a bit of introduction and recap about the topic Surds and what you need to know, and then we're going to go to now the questions, and we're going to tackle examples, and we're going to then tackle questions. So join me. I hope you're going to understand, and I hope you're going to love this class. Thank you. So as I said, today we are looking at the topic Surds. So I'm just going to write a brief introduction on the topic so that we can know what we are looking at. So we know that the roots of rational numbers called Surds. We see that the roots of rational numbers that give irrational numbers are called Surds. So examples of irrational numbers can be square root of 2, square root of 3, which when you try to find them, they'll give you decimals. And like we see, for 2 is 1.41, for 3 is 1.73. So those are what we call irrational numbers. And irrational numbers can be in the form of a over b, maybe 2 over 5, and such. So when asked the order, you see that the order of Surds is the index of its roots. So assume you've been given an example to find the order of this, the square root of 3. This is the square root, so now it's of order 2. Given maybe 4, you've been told to find the cube root, it's on the third order, and maybe given a, the nth root, it's of the nth order. So this is just introduction about what you need to know, and we've seen when asked to find the order, you find it's the index of its root. So for here it will be the third order, here the second order, and here the nth order. So now let's go further and look at like and unlike Surds. So now we are looking for the like and unlike Surds. We want to know the difference. So when to know when a Surd is like terms and when they are unlike. So you've been given a Surd, maybe let's say this a, the eighth root of b, and as you can see here we have two factors. We have a and root b. Remember, a is a rational Surd, and root b is an irrational. So we always say that Surds are like Surds. So they are like Surds when they have the same irrational number and otherwise. So if maybe you've been given a root b can say they are like surds because they have the same irrational number. So this is just for the like and unlike surds. I hope you've understood that we only say that surds are alike if they have the same irrational number. So now let's look at rationalizing the denominator. So under the topic, rationalizing the denominator, we can just, from what you read here, we see that when a fraction has a surd in the denominator, we normally rationalize the denominator by multiplying the numerator and the denominator by a surd that will make the denominator rational. Now let's go to an example. You have 1 over 3 plus square root of 2. So when given such, we've been told when a fraction has a surd in the denominator, like we can see from the denominator, it has a surd in it. We normally rationalize the denominator by multiplying the numerator by a surd that will make the denominator rational. Note, in order to make the denominator rational, what you do, you will multiply by this number, but the sign will change. Because here it's a positive, you will now multiply with a negative. So what you do, solution, so it's 1 over 3 plus root 2. You will now multiply numerator by 3 minus root 2. Like I said, you change the sign in order to rationalize the denominator over. You multiply also below 3 minus root 2. So this is how you're supposed to do it. So when multiplying 1 times 3, it becomes 3. 1 minus the square root of 2 becomes just the root of 2 over. So when you're doing multiplying now the denominators, what you need to do, let me just add this. So when multiplying the denominator, that is 3 plus root 2, you multiply with 3 minus root 2. So what you need to know here, when this, we are going to use expansion, and what we do here now, while removing the brackets, you take 3, this 3, and you multiply by this whole number, 3 minus root 2. Then you take positive, the square root of 2, you multiply by the same 3 minus root 2. So this becomes 3 times 3 is 9. 3 minus the square root of 2. What you need to know here while multiplying, this number comes before, so it becomes minus 3, this 3, then root 2. It normally comes before the root because you cannot multiply them because this 3 doesn't have the square root sign. Then here plus root 2 times 3, again the 3 comes before the root. Then root 2 times minus root 2, positive and minus becomes a negative sign. And remember when working out that is root 2 minus root 2. No, we multiply because we're opening the brackets. So what you need to do, this is the same as 2 raised to a half. Root 2 is the same as 2 raised to a half times 2 raised to a half. Remember the indices formula, what we normally do, we take 2 because they are of the same base, then a half plus a half because it's multiplication. And remember we touched on this last week, so in case you have a problem, you can actually go and see the previous video in order for you to understand what we are doing here better. So 2, a half plus a half is 1, so 2 raised to 1. This is just 2. So root 2 times root 2, it becomes 2. I hope you've understood what we've done here. So what we do here, remember the like terms, 9 and 2, so 9 minus 2 becomes 7, and negative 3 root 2 plus 3 root 2. Negative and positive, so this will cancel out, so you are left with 7. So your answer will be the numerator and the denominator which you are calculating here is 7. So your answer will be 3 minus root 2 over 7. So I'm hoping you've actually understood. Let's now look at the second example. So now let's look at example 2. You've been given 2 2 root 3 over root 5 plus root 2. So remember, when given such, what you need to do, you rationalize the denominator by, changing the sign here. So you multiply both sides. That's step 1, root 5 minus root 2. Remember, we change the sign to negative. Also, down below, you'll have to multiply this by root 5 minus root 2. So that's step 1. So step 1, we just indicate the change of the sign both on the numerator and the denominator. So that's step 1. So now let's go to step 2. So that you don't confuse, you can actually separate them and work with the numerator first. You just find the solution for the numerator. So this becomes 2 root 3, you multiply by root 5 minus root 2. So basically here you open the brackets. So now you open brackets. So 2 multiply 2 root 3 times root 5. So what you need to do here, because outside you will multiply now these two together. So 3 times 5 becomes 15. So it becomes 2 root 15. Because here it's 2 times 1, 2, 3 times 5, 15. So you multiply the ones, the outside ones, the rational ones together. Then you multiply the irrational ones together. That is how you multiply them. Then you come here, there's a negative sign. Again, 2 times 1 becomes 2. 3 times 2, 6. So root 6. So your numerator, this becomes the answer for your numerator. 2 root 15 minus 2, 6. So now let's go on the denominator. So step 3, we work with the denominator. Comes root 5, let me just write it, plus root 2 times root 5 minus root 2. So what you need to do here, remember basics from book 2 when we were doing, factorization. So what you need to do, you take, for expansion, you take this root 5, you multiply by root 5 minus root 2. Take this and multiply with this whole, then plus, remember the sign, 2, you multiply with again this minus root 2. So 5 and 5, like I said, these two numbers are alike, so it becomes automatically 5. Like we had done before, let me just do it so that you can understand. This is the same as 5 raised to a half times 5 raised to a half. Using indices, it becomes 5, a half plus a half, 1. So it becomes 5. So you just come here and indicate 5. Remember, when the numbers are the same, your multiplication becomes just, that number. And here we multiply the ones that are inside 5 and 2. It becomes minus root 10. Then here, 2 and 5 again, plus root 10. Then 2 and 2, remember there's a negative sign. Positive and negative becomes negative. 2 and 2 becomes 2. So what you need to do here, plus root 10 minus root 10 plus 10, this will cancel out because of the change in the signs. It's the same as minus 1 plus 1, which becomes 0. So the 2 cancel out and you're left with 5 minus 2, which is 3. So remember your numerator, we got the answer to be 2 root 15 minus 2 root 6. This was the answer for the numerator, and this is the answer for the denominator. So you just come and put them together. 2 root 15 minus 2 root 6 over 3. And this becomes your answer. Also, you can note, when given such, this the rational numbers are like the 2 and 2. So you can also opt to simplify it further by bringing 2 outside, because they are both 2 and 2. Then you're left with 15 minus root 6 over 3. So your answer can be, you can simplify it further to 2 over 3 root 15 minus root 6. So that can be your answer.